Hey guys, and welcome to another video. As you can see today by the title, we are doing radians to degrees in math. I'm just gonna get into the topic. Don't want to delay anything. So before we begin, we're gonna you guys need to know some prerequisites. I'm gonna be mentioning them throughout the video, and if you ever get confused, like what is this, I would definitely recommend learning that right away, because you're not gonna understand you might understand it. You will understand if you don't know like one or two things. I think arc, measure, and length. But besides the fact, I would not recommend learning this too early, because you can if you want to. I'm not going to stop you, but I would definitely recommend doing prerequisites. We might make videos of those later on. Yeah. And the reason why we're just doing radians to degrees out of the blue is because we're just we want to I feel like a lot of people struggle with this topic. It might be like you might only know the conversion. You might want to know a little in depth about it. So that's why we are going to be covering that today. So yeah, without further ado, let's get into it, guys. So what are radians? We need to take that into fact first. Radians. What are they? So radians are basically how many times we should know radii, and this is the center point. It's not really good, but I guess we can deal with it for now. How many times? I'm just gonna draw another arc. I'm gonna draw one arc. So how many times this one radii or one radius can fit into this arc? So the arc measure. It's not the length. We might get confused with that, but it's the arc measure. So how many times this radii or this radius can fit into this, or not that, but this? Yeah. So that's the conversion. So that's a thing that might confuse a lot of people. So yeah, how many times a radius can fit into an arc of the circle? And we should know arc measure by now. Just gonna give you guys a little prerequisite on a little introduction. So whatever the angle of that arc is, that's gonna be the measure. Say this is theta. Then you might get confused with length. Length is actual like units, like centimeters, meters, like that. Measure is like the angle itself. So it might not make a lot of sense. I would suggest watching other videos on it. We might make it, so stay tuned for that if this is getting a little confusing. So arc measure is the angle measure of this. So we could use to represent that in radians, which how many times one radii can fit into this arc measure. And it's not length, it's the measure of the arc. So that might be a little confusing to you guys right now. So I'm gonna scroll down a little bit, and I'm gonna try to derive something where we can use it to convert degrees into radians. So first, let's start with the formula 2 pi r. We should know this formula by now. R stands for radius, and 2 pi, pretty straightforward. Pi is the 3.1415 ... and 2, we should know that by now. So yeah, so R is radius. This is the only hidden factor in this. So and we should know this by now, that R is how we determine the circumference of a circle. The measure, not the measure, but how long, I don't know how to say this, but like units, center of the circle. I'm just gonna draw another radius. So how long this is. So say like 5 meters, depends on the circle. So yeah, how long that is. So so this is where we start getting into some interesting stuff. So I'm gonna take a little tiny example. So say 2 times 3. We could think of this as 2 groups of 3 dots. 2, 3. We could think of this as 2 groups of 3 dots, or vice versa. 3 groups. Looks like little people, but 3 groups of 2 dots. So we could think of it as groups. So if we think of it as groups, we can do 2 pi groups of the radius. So pi is an irrational number, so you're gonna need to most people approximate to 3.14. So I guess you could say 6.28. So we could think of this as 6.28 groups of the radius. So this radius, any radius, it depends on the circle too. So any radius. So say the radius is 5. So so basically we just do 6.28 approximately. Remember, that's important. Times 5 is equal to the circumference. So I mean that changes the game right now, because that basically means whatever the radius is, and let's get into radians now. So radians and radius are basically the same now, because I mean the rad, even you could even think it stands for radius, and it probably does. I'm not too fond of the history behind that. So so basically we can think of 2 pi radians. So see, here's the thing: 2 pi groups of the r, so of the radius, are cover this entire circle. So we could think of it as 2 pi radians. So how many times one radius fits around, which is basically this equation. That should make sense. It's getting a little messy here. I'm just gonna erase some. I'm just gonna erase all of this actually. So remember, I'm gonna restate it a little simpler. So 2 pi r and 2 pi. So remember, guys, I stated this before, I'm going to state it again. So 2 pi groups, or 2 pi, so the radius, one radius, it can be anything. You could literally call it x2. So so x, or the one radius, times 6.8 approximately, or you could think of this as 2 pi. I'm just going to keep it at 2 pi. I'm not going to evaluate 2 pi. Is equal to the circumference, the whole circle, like the length of the whole circle, like, yeah, the outside of the circle. And now we know that so now we know that radians are the measure of how many times a radius can fit into a certain part of the circle. But what if we think of this as 2 pi radians fit into the whole circle? So we could think of this as the circumference is 2 pi radians. And remember, guys, the radians is converted to degrees. So remember, we're measuring the measure of this circle. We're not going into the circumference of it, we're going into the measure of it. So the measure is 2 pi. And I mean, degrees, we know one circle, you need to know this too. One circle is 360 degrees. You should know this. One circle is 360 degrees. And if we're converting radians to degrees, then basically what that means is 2 pi radians is equal to 360 degrees. This is a symbol for degrees. We should know this. Prerequisites. This is how we derive this. And we can simplify this. I'm going to simplify it in a few minutes. Just give me a moment. So I'm going to let you guys pause the video and just take all this in. It might be a lot to take in. Rewind. I mean, for me, it does help to think through a little. So I'm just pause the video. I'm just going to... Okay, you should be back by now if you weren't. That was a weird, awkward pause then. So I'm just going to erase all this now. So now, sorry about that, fumbling today. So if we delete this and we go back up to this, and I'm just gonna delete this too, and let's draw this up here. So 2 pi rad. I'm just gonna do radians for short, rad. I don't think that's the proper thing, but in this, for the sake of the video, I'm just gonna do rad. Is converted 360 degrees. So we can simplify this. We can just divide by 2 on both sides. Remember, guys, what you do to one side, you have to do to the other side in equations. So we can 2 cross out, and then this becomes 180. So pi rad, or radians, is equal to 180 degrees. So coming back to the statement I said earlier. Coming back to the statement I said earlier. What you need to do to one side, you need to do the other, right? So first, let's talk about the conversion between radians to degrees. I'm just going to focus on that first. Or actually, no, degrees to radians, because that might be a little easier, because we know degrees a little more. So now we can divide 180 by both sides. Divide 180. And we get pi divided by 180 radians. I'm not gonna simplify pi. I wouldn't recommend like entering this into a calculator and doing that. Like getting a decimal point answer. Like in your notes, and if you're like using paper, I would suggest having this like it is. Yeah, and is equal to 1 degree. So coming back to what I said again for the third time in a row, coming back to what I said, what you have to do to one side, you have to do the other. We can even test this out. So maybe we want to convert degrees to radians. So say we have a little circle, like I'm barely gonna draw this, and we want to find. I'm just gonna draw. I'm not gonna go too in depth, and we want to find how many radians this is, and let's say the radians, the degrees is 50. So 50 degrees. So now, remember guys, what you do to one side, you have to do to the other. I'm going to say that a lot. Multiply by 50 on both sides. So I'm just going to barely simplify this. So 5, remember 0, 0 cancel out. You can't really simplify 5 and 18. So 5 pi divided by 18 radians, or rad for short, is equal to 50 degrees. So some people, if you do know what radians are and you know the conversion, you might think of this. I mean, you might not be watching the video, but if you want to get a deeper understanding of it, you might be. So you might know this conversion as if you're converting degrees to radians, multiply it by pi by 80. So that's something you guys can remember. And for vice versa, I'm just gonna erase this 1 second. Give me a second. Sorry, it's taking a little while. I'm gonna keep that actually. Yeah. So we did pi. So what helps me is, instead of having the 2 pi is equal to 360 degrees, you could keep it like, you could always start off with this as your thing if you don't remember this stuff. Or you could just do pi radians is equal to 180. That's how I started it. So pi radians is equal to 180 degrees. If you want to convert radians to degrees, so this way, divide pi by both sides and divide by pi. 1 rad is equal to 180 divided by pi degrees. So that's this, and it's basically the same thing as converting degrees to radians. We multiply however many radians we want, and multiply x, I guess. I mean, we don't really know what the radians are. I'm just using this. Multiplied by x on both sides, and then you get x radians is equal to 180x by divided by pi. So that's how this works. In a future video, I'm gonna have some exercises, because this might be a lot to take in at one point. In a future video, I'll do some exercises on this, and with answers, of course. And yeah. So, a little bit recap. All this derives from, 2 pi r, and then it goes all the way down, and then we realize that since radians are how many times a radius can cover a certain part or arc measure of the circle, we can basically think of this as 2 and radius. So 2 pi radius cover an entire circle. We can think of it as 2 pi radians instead of 2 pi radians, I'm going to actually write it out, is equal to 360 degrees. So yeah, and then conversion, divide by 2, 180, and then pi rad is equal to 180 degrees. And I mean, see, this is how you understand it. If you want to just if you're just taking if you just want to practice this, remember, guys, if you want to convert degrees to radians, you multiply. I mean, if you want to memorize this, if you want to multiply the degrees by pi by 180. So x is equal to degrees, any number of degrees. But if you want to do vice versa and radians to degrees, you can do 180 by pi multiplied by whatever, I'm just going to y this time, whatever the number of radians is. So yeah, so guys, this is how you convert radians to degrees. If you did not understand or were lost, please do let me know in the comments below. And definitely, please, and if you guys didn't understand much of this video, you might not have, like, you might not know the prerequisites. I'll in the link in the description sorry, not link. I'll leave some I'll tell you guys what you need to learn before doing this. So yeah,